we're going to be spending the next couple units talking about quadratic functions and doing some factoring. So just first assignment's going to go through and just review some of the terms that we're going to see as we graph and talk about quadratics. So I'm going to run through these fairly quickly. And we're only going to do a couple of these, but we're going to take a look at exercise 1B. We're going to answer this one. I know we did function notation a lot. So again, remember you're just taking the number, the value that will represent x, in this case 2, when you're plugging it in for x. So it would be 2 parentheses 2 squared minus 5. And then you could type that in the calculator, and for this you'd get 3 out as an answer. Okay, so I'll show you how to type it in. You go ahead, turn your calculator on. It's just like as it looks, and we spend a lot of time in Unit 1 doing this. So that's how you would get your answer of 3. And then you could try some of the other ones on this. But we're going to move on to exercise 2. This one talks about graphing an algebraic or a quadratic function. And again, sometimes they call these graphs parabolas, kind of like underline. And they want us to do a certain domain. They want us to do -3 to 3. So just like we've done graphs before, you're going to go ahead, go to y equals, type in x squared, and hit second graph. And they want the values from -3 to 3. So I got those on the table over there. I'm going to go ahead and write these in. I'm going to go ahead and graph them on the graph. So we got -3, 9, -2, 4, -1, 1, 0, 0, and then go in the opposite direction. Now again, you're going to see that there's some y values that repeat. So this is a graph, a parabola, is a graph that's a function, but it wouldn't be 1 to 1 because it doesn't pass the horizontal line test. So we did B, we sketched a graph. The turning point for this is going to be at 0, 0, and that's the place where this graph turns at. So right here, goes into the opposite direction. The equation of the little axis of symmetry is the line that cuts the graph in half. So that line is the y-axis in this case, but as we write the name of that equation, it's going to be when x equals 0. Because every point on this line here has a coordinate of 0 for an x value. And then the graph is going to be increasing when x is greater than 0. So from this point, our turning point, going to the right, you can see the graph is going up in that case. So now we're going to move on to the back of this. And for exercise 3, pretty similar type of function. This one's got -x squared plus 6x plus 5. They want us to use a table to determine the turning point. So you can find the table, the turning point on the table, after you type it in. By hitting second and graph, and then you're looking for the place where you start seeing those repeat y values. So right here at 314, that looks like that's where our turning point is going to be, because then you see y values on each side starting to repeat. They want us to graph this. So I'm going to go ahead and start graphing some of the points. So we got, looks like -1, -2, 0, 5, 110, 213, and 314, and then we start going down in that same pattern. So we're going to start having some repeats for the y values. So I'm going to go ahead and draw that. And again, the points being in the right spot are more important. And it says, why does this parabola open downward as opposed to y equals x squared, which opens upwards? Well, in that case, it's going to go fall into the a value. The a value, in this case, we're talking about that first value, is -1. So if we have an a value that's less than 0, when it's less than 0, it's going to open downward, whereas a positive value greater than 0 is going to open upward. Now they're asking us what two consecutive integers of the larger solution to the equation lie. So in this case, looks like over here, we have it pass through the x-axis. So in that case, it's going to be between 6 and 7. Now there's another one between 0 and -1. Those are our zeros, but again, they want the, like it says, the larger solution in that case. Now, you could take a look at exercise 4 on your own. It's asking about some of the key points. And really all they want you to do is graph the equation, and then they talk about the zeros, which we just touched on, the y-intercept, and the turning point. Okay, so you can kind of fill those in based on what you see on the table and the graph. But if you do see it on the graph, just double check and make sure you see it on the table as well.